In the previous video, we saw how to simulate a three-phase uncontrolled bridge rectifier. In that case, we didn't really consider the source inductance. In practice, there is always going to be a source AC side inductance, be it from the transformer or a current limiting inductor. So let's input then to the source side some inductance. We take an inductor, rotate with Ctrl+R, put it here. I will define it as a variable L in, that means the input side inductance, and initial current I take it to be 0. Let's hide the name and copy it 2 more times. And let's take an M file to define the variables for our case. Let's say L in is equal to 100 microhenries. So this is the input side inductance. Normally there are also a small amount of resistance present from the grid impedances, and for that we take a resistor, Ctrl+R to rotate, just hide the name and say it has a value of R in, and let's place that here. And let's define R in to be 2 milliohm. Input side resistance. We can also run the simulation directly from the script, from M file. For that we need to write sim, and then you see the name is already present there. I need to check which one I should select. I should say B6U, then PLECS. Is there a file name? What is? Okay, I didn't save it to that folder. Let's take save as. Let's go to AC/DC B6U. It's actually there. Yes, please. This is really .slx. Let's see, if we run this, we should be able to have that program running. Change the folder, please. Let's check what the problem is. It seems I saved my M file and a Simulink file to different folders. So I just adjusted the settings so that we can run the script from the same folder where we saved the SLX file. So as I was mentioning, we have the two variables for the input side impedances of the converter. And as I said, we can run the simulation also from the mat.m file. So let's run it here. So in that case, we need to write sim and the name of the Simulink file. If we run it, then it will shortly show here running, and then it is done. Let's check the values then. So here we can clearly see the effect of the source inductance. We see the input side voltages on the top are not sinusoidal completely. We have some notches here which are lost due to the inductance values. Depending on how high the inductance is, the depth of the notch will vary. The more the resistance, deeper the notches are. And the currents are also having, for example, a harmonic effect. So since they're not sinusoidal sources with inductance, we have also the effect on the current. And to the third curve, we have the DC side voltages. Now, if you see, we also still have the RMS cursors here set up. We see there is a part of voltage is lost due on the AC side impedance. For example, it's not completely 700 volts, but less than 700 volts. And also the effect on the DC voltage is seen here. It says 917 volts. For example, if we take even less inductance on the AC side, let's rerun it. And here you see the loss of voltage is comparatively smaller than the previous one, in which case we had 100 microhenries, and it's much more sinusoidal, the curves. I will show you later if we have a real transformer here and also current limiting chokes, how that would affect the operation of the converter. And in future videos I will also show how to design for example a more realistic semiconductor devices, be it a diode or thyristors or other types, depending on the reverse characteristic curves. But that's now for this video. Thank you.